Okay, welcome to the last video in this series covering semester 1 final exam review 57 to 60. And what we're supposed to do on these next three problems is to factor the expression. You always want to look in these problems for greatest common factor first. And in this case, there's a 6 in all three of these. So we'll pull that out. 6 times 9x squared 54 divided by 6 is 9. And when you take 144 divided by 6, you get 24. So we get negative 24x there. And finally, 96 divided by 6 would be 16. And if you were to check this step, you just distribute to get back up on that top line. Okay, we're at the point where we're going to be able to factor this. And you'll notice in this problem that we have a perfect square up in the front. 3x times 3x would give 9x squared. And then we have a perfect square at the back. 4 times 4 would give 16. So in all likelihood, this is a perfect square trinomial that we're dealing with. So let's just do the last check here. Square root of this would be 3. Square root of this would be 4. 3 times 4 is 12. When you double it, you get 24, which is the correct middle term. So now this is actually a very easy problem at this stage. You just break it down. 9x squared would be 3x times 3x. The 16 would be 4 and 4. 4 times 4 is 16. And you always borrow the sign from the middle term, so you're going to use a minus on both of these. And let's check it before we move on here. Does the first times first give 9x squared? Yeah, that worked out okay. Does the last times last give 16? That worked out just fine. And then you get a minus 12x and a minus 12x, which would give negative 24x. So the middle term works out too. The only other thing you can do on this is write it in shorthand. Since it's 3x minus 4 times itself, you can just put a squared there, and there's your final answer. Okay, on number 58, you do what I've advised you always to do. You always look for a greatest common factor. And it may be that there is none, but in this case, all of these divide by 3. Actually, I'm going to drop down a line here. 3 times 2x squared minus 1x, and 45 divided by 3 is 15, so get a negative 15 there. Okay, this one doesn't have perfect squares on the ends. For instance, 15 is not a perfect square, neither is 2. So we're not going to do the same thing we did on the last problem. What you're going to do here is label the first and the last and multiply them. Okay, now once you've done that, you're going to try and find the outside term and the inside term. And you do that by trying to find two numbers that multiply to give negative 30 and add to give negative 1. Now, if you list the possibilities here for 30, 1 times 30, 2 times 15, 3 times 10, 4 doesn't go into 30, and 5 times 6 is the last choice. The only one that has this possible sum here is the 5 and 6. And you might have to play with the signs to get that. So let's try it, 5x and 6x. To get a negative 1 out of this, you have to put a negative on the second one there. Now just double check before you move on, because this is the crux of the problem. 5x and negative 6x add up to this one. And the same two terms, 5x and negative 6x, multiply to give this negative 30x. So you're ready to move on. All right, and the way this works here is you're going to set it up down here. And to do this first part here, you want the greatest common factor of the first term and the outside. And that would just simply be x. Then you go back to the first term, but this time with the inside term, and the common factor between those is 2x. Now we have to get this outside term to be 5x, so we better put a plus 5 down here. And the inside term right here has to be negative 6x, so we better put a minus 3 there. And just as one last double check, let's continue this. Negative 15 for the last. Yep, that worked out. And first times first, here's 2x squared. Yep, that worked out. So this problem is done, and here's our answer down here, the factored version of it. Okay, problem 59 is actually one of the easy styles of problems. There's no GCF, so you check that first, but there is none on this problem. But we do notice that there's a perfect square on each end. 49 is a perfect square, and so is 16. And they're separated by a minus sign. So this is called the difference of squares problem, and they're very, very easy to do. You have to use opposite signs. And you put the square roots, in this case 7x and 7x, and 4 and 4. And that should do it for us. The only thing I'm going to do here before I move on is check it. 49x squared. We get a 28x there and a minus 28x there, which would cancel. And a positive 4 times a negative 4 gives negative 16. So everything checks on this problem. Okay, the last one I'm going to do is a square root of 112. And we're going to break this up into a perfect square in this first square root, and the remainder in the back square root. Now the way you got to do this here is go to your y equals key on your calculator and display the factors of 112 by typing in this. And when you go to your table of values, let me go ahead and do it myself, and I'll write down what you would get here. Okay, you get 1 times 112, 2 times 56, 3 doesn't go into it, so you get some weird decimal, 37.33, 4 times 28, and the next one that goes into it is 7 times 16. You have to scroll down to find that one. 8 times 14 gives 112. And when you keep on scrolling down, eventually you got 14 times 8, which is just the start of the repeat versions of these. So when you see a one turnaround, we have 8 times 14. When you get to one that repeats, going backwards, 14 times 8 in this case, you know you've done all you need to. Now, what you need to do on this is move your cursor over to the second column and cruise down this column until you find the first perfect square, in this case 16. So you know that that one goes up here, and it'd be 16 times 7. And the front half of that then, because it's a perfect square, simplifies, and you get 4 root 7. And you don't have to use two colors on it, but 4 root 7 is the correct answer to my problem, the square root of 112. You're not being asked for decimals here, so don't just type square root of 112 on your calculator. Okay, so this ends the the semester 1 review for Algebra 2, and I hope you study hard and do well.